Okay, for the last topic on this worksheet, we're going to look at finding inverses and then looking at solving some equations, okay? So this is kind of just a way to wrap up this first section where we talk about inverse trig functions, okay? So for example 11, it says, consider f of x equals -3 times cosine of x plus 2 where 0 is less than or equal to x, which is less than or equal to pi. So they're basically limiting us. They're saying our domain here is from 0 to pi. Okay. So find f inverse. So let's think about this. We talked about this at the very, very beginning of this worksheet. We were looking at f of x equals the square root of like x minus 1 or something. Okay. So what we did then is we replace the f of x with just a y. So we say, okay, this is now y equals -3 cosine. Let me fix that. Cosine of x plus 2. And then we literally just flip-flop our x and our y. So we let y equal x equal y. So this becomes x equals -3 times cosine of y plus 2. And then we have to find a way to solve for y. So the very first thing we want to try to do is isolate the cosine y. And if we can isolate the cosine y, we have a little trick up our sleeve that I'll show you in just a bit. So the first thing I'm going to do is subtract my 2. So that gives me x minus 2 equals -3 cosine of y. And I want to get the cosine y by itself, so I need to divide everything by -3. So what that gives me is -x/3 plus 2/3. -2 divided by -3 is +2/3. And then the -3's on the right, they just divide out to be 1. So that leaves me with cosine of y. Now here's the thing. We can take the inverse of like the inverse cosine of cosine, and it basically will just give us the input. Okay, so our goal is to free the y from the argument. Okay, so if I can take the inverse cosine of both sides, that becomes a thing that I can do. So I could say, okay, cosine inverse of -x/3 plus 2/3 equals inverse cosine of y. And these two things right here, they will undo each other. So that gets the y by itself. And so we're going to say here that y equals cosine or inverse cosine of -x/3 plus 2/3. And then once we solve for y, we can finally say, okay, well, that becomes f inverse. So this is now f inverse, which is inverse cosine of this mess, -x/3 plus 2/3. Okay, so it's kind of down here in the corner, but I think I was able to squeeze it in. Okay, so there we have it. Now we need to state the domain and range of f inverse. Well, that can be not the easiest thing ever. Okay, so sometimes if you can go back to your original function and state the domain and range there, then we can just flip-flop them and get the domain and range of the inverse function, okay? So let's really think about what's happening here. So remember, our original function is like right here, okay? Now, ordinarily speaking, cosine does this. So we know the range of like normal cosine is -1 to 1, okay? And its domain, that's the range. And then its domain, it keeps going forever. Please keep that in mind. It goes forever. The domain is negative to positive infinity, okay? So that's just regular cosine. But the function that we had to begin with is not regular cosine. It has a vertical stretch and a vertical shift, okay? So let's think about what that does, okay? So we know this is like regular cosine. It has a range of -1 to 1, okay? -1 to +1. But when we stretch it and then shift it, that's all going to change. So let's think about what that's going to look like. So I'm going to erase this graph of just regular cosine, okay? Now, when we stretch our graph, we're basically it's really the amplitude. We've been calling it the amplitude of these trig functions. So the amplitude is basically the height of the wave. So this right here tells me that instead of going from +1 or -1 to +1, that's going to really triple. Okay, so what this is really going to now be, please let me erase. There we go. What this is really going to be is this is now positive 3 and this is negative 3. Okay, but we also have a vertical shift. So that vertical shift is going to take that whole graph, which is now negative 3 to positive 3, and it's going to shift it up 2. So now my negative 3 becomes negative 1, and my positive 3 becomes 5. So the range of the actual function is negative 1 to 5. And then the domain is not officially 0 or negative to positive infinity. Remember, they gave us a domain right off the jump. They said, hey, y'all, we're restricting our domain to 0 to pi. Okay, so be really careful with a question like this. Again, you can kind of think of the original just cosine function, okay, know what its domain and range are, but this is a cosine function that's had transformations applied to it, which is going to shift our range, and then we were given a domain right off the jump, okay? So when we're talking about the domain and range of F inverse, they're going to flip-flop. So the domain of F inverse equals the range of F, and the range of F inverse equals the domain of F. So let's see what the official domain and range are. Well, the domain of the inverse function is going to be the range of the original function. So it's going to be negative 1 to 5. And then the range of the inverse function is going to be the domain of the original function, which we were given right off the bat as 0 to pi. So there you have it. So in a situation like this, it might be easier to find the domain and range of the original function and then flip them and apply it to the inverse, okay? Last up, we have a couple of equations that we want to solve. So we are going to look much deeper into solving trig equations, but for now, we've got just some really basic stuff. So it says solve each equation for x. So I have 12 times inverse sine of x equals 3 pi. So our goal when we're solving is to basically find the value of x. So we have to somehow get this inverse sine alone and then find a way to free the x from that, okay? So the first thing I want to do is just get inverse sine alone, and my issue is this multiplication of 12. So I essentially want to divide both sides by 12. Well, that's going to leave me with inverse sine of x equals, well, 3 pi over 12 is going to reduce to just pi over 4. And it's like, okay, that's cool. So inverse sine of x equals pi over 4. Okay, well, what is that going to be for us? So we want to basically free the x from the argument. And in order to do that, I can take into account the fact that if I take sine of inverse sine, they'll undo each other. Okay? Ooh, I got a bug flying in my face. All right, so I want to take sine of both sides. So sine of inverse sine of x is now going to equal sine of pi over 4. Well, these two things will just undo each other, okay? So that leaves me with just my x. So I've freed my x from the argument of inverse sine, and that is now equal to sine of pi over 4. So if we can envision the unit circle, pi over 4, it has that point on the terminal side of root 2 over 2, comma root 2 over 2. So we would say that x equals root 2 over 2. Okay? Now for part B looks like a wild, crazy mess, but it's actually not too bad. We just have to kind of slow down and embrace the process. So the first thing I want to point out to you is we have inverse tan of x minus 5 inverse tans of x. As weird as these look, these are basically the same as like terms. So remember, when we have like terms, we can combine them. So if we just kind of pretend the tan inverse is like x, we have 1x minus 5x, that would just be negative 4x. Well, the same concept is going to apply here. We're going to get negative 4 tan inverse of x, okay? So this is negative 4 tan inverse of x minus pi over 3 equals 2 pi over 3. Now, my goal is to get the inverse tan of x alone, okay? The first thing I need to deal with is that minus pi over 3. Get rid of it. So how do I move the minus pi over 3? The opposite of subtraction is addition, so I'm going to add it. So let's see, that gives me negative 4 tan inverse of x equals, well, if I look at right here, 2 pi over 3 plus 1 pi over 3 is 3 pi over 3. And 3 pi over 3 is just going to reduce to plain old just pi. Okay? So I've got negative 4 inverse tan. I think I said tan inverse before. You generally say inverse tan. So negative 4 inverse tan of x equals pi. I need to get the inverse tan alone. So I need to undo that multiplication of negative 4 and inverse tan. So I'm going to divide both sides by negative 4. And that gives me inverse tan of x equals negative pi over 4. Now we want to get the x by itself. We want to get that x out of the argument of inverse tan. So I have this really cool trick up my sleeve where I can just take the tangent of both sides. So tangent of inverse tangent, they just undo each other. So I'm left with x, and x equals tangent of negative pi over 4. So you can do this two ways. You can take into account that tangent is an odd function. And so that tells me that if I have f of negative theta, it equals negative f of theta. So since tangent's odd, I can just say that this is equal to negative tangent of positive pi over 4. And a lot of times students like to find angles that are in that quadrant 1 because we typically memorize quadrant 1. So if we are looking at quadrant 1, we have this angle right here, which is my pi over 4, and it has an ordered pair on the terminal side of root 2 over 2, comma, root 2 over 2. Well, if I take the sine and divide it by the cosine, that's going to equal 1. But remember, I've got this negative right here, which would make it negative 1. Now, if you wanted to just leave it negative pi over 4, you absolutely could. So if I were looking at negative pi over 4, that would put me down here. And that has a point on the terminal side of root 2 over 2, comma negative root 2 over 2. So when I take sine and divide it by cosine, I get negative 1. So either way, you'll get negative 1 here. And you can back substitute this stuff and check your answer if you want to, okay? But there you have it. So this is an incredibly long section. We've done a ton with inverse sine, cosine, and tangent. And I encourage you to really, really understand these. Pay a lot of attention to the domain and range, okay, because that's going to be a big part of how we successfully solve these problems, okay? When we get to the next section, we'll look at inverse secant, cosecant, and cotangent, okay? So big section. Pat yourselves on the back if you made it this far. You're doing great, all right?